Now let's review this figure 14-4. Notice it's a basic induction motor operation. And I think this is an excellent drawing to illustrate what we're trying to show you. Now let's look at the very top. We have a plus coming in North Pole. We're using the plus as an illustration. Then notice you have north on the left-hand side of the drawing, and it's pushing, repelling that rotor out. And that magnet is representing the rotor. And then notice we have a north and a south, and that attracts and pulls it in. Now once it gets here, the alternating current changes it, and it becomes a south pole, and it pushes it out. Then you have the north and south here attracting it, pulling it in. Then you have a north and north pushing it. So you have a push-pull action continuously of that rotor. That's why you have a number of poles. You know, you have more poles, and you're going to have more magnetic field flux, and the motor can have a different speed and have more power. So, but we're just using two basic north and south poles here that are electrified with alternating current, so the poles continuously changing, plus, minus. So in other words, on the plus, the north, the pole that has the north on it, or basically, as it alternates, the current goes from a plus to minus, that changes to south, see? And that provides this push-pull action. And you can see at the very bottom, we have a south and south pole, and it pushes it out. We have a north pole changing here that would push it out. And that's illustrating what would take place at the very top, see, based upon a south or north pole. And that's what your figure 14-4 is illustrating, how the electromagnets will have a push-pull action and operate as this figure 14-4 illustrates.